We have now seen how we can target the pressure in the storage tank to be 1.1 bar by trial and error, where we are changing the output pressure of the pump, and then we confirm that the pressure at the end of the pipeline it is 1.1 bar. Now let us use a much more educated way of doing this using a controller in Chemcad. Let's take a look at our flow sheet again. In our feed we have 200 tons per hour of water in the feed supplied from our tanker at 1.05 bar, and we have a pipeline which is 900 meter long, an elevation of 30 meters, and we have specified a roughness factor. The diameter of the pipe is 225 millimeter. Remember, this is taken as the internal diameter of the pipe. However, if you specify the pipe schedule here, Chemcad will use the specified pipe diameter as the nominal diameter, and it will calculate the internal diameter based on the nominal diameter and the schedule diameter. Let's just quickly look at the Chemcad help in this. The pipe schedules are given right at the bottom here. The pipe schedules are given right here at the bottom here. For schedule 40, these are the nominal diameters given in inches. If you would like to get them in millimeters, you can use your unit conversion, or you can use the table that we gave in class that it is in the SI unit. If the nominal diameter that you are given, or the outer diameter that you are given, does not fall within the range that is given here, you can use this formula here in the help to calculate the thickness of that pipe, and then hence you can use that to calculate the internal diameter of your pipe that you can take back and use into Chemcad here. Just to recap on this, if you specify the diameter here, it will be taken as the internal diameter if you have left the pipe schedule blank. If you enter the pipe schedule here, Chemcad now starts to use the pipe schedule to calculate the internal diameter from the schedule tables. The one other thing that we have here is the number of segments. This number of segments just allows you, if you have a given pipe length and you want to divide it into sections so that you can do calculations on the sections individually. And then Chemcad also allows you to specify optional pipe case studies. We are given 225. We can specify a case at 220 and another case at 200. Chemcad will report the pipe diameter that we have given it here, which is 225, and in addition it will also show us the options for the given pipe diameters that we have given in the optional pipe diameter. And we have stated that we can also indicate the properties of the fluid that's flowing through the pipe, if you want to change them from what Chemcad is calculating. Please, when you specify here, remember to choose use my properties below, otherwise Chemcad will continue to use the calculated values if you do not check this checkbox. The calculated results after Chemcad has converged, you can get them from the calculated results tabs, and then the valves and fittings in the valves and fittings tabs. As we have said that Chemcad gives you some of the standard valves that you have. If there are some valves that you don't have here, or the fittings that you don't have, you can also press F1 and then access the Chemcad help, which gives you a lot more, which gives you a table with equivalent length coefficients of other fittings and valves. You can also use your design handbooks to find your equivalent length coefficients, which you can now come and enter here as user specified valves. Remember, in our example we are given the viscosity and the density of the fluid, which we have been told that it is toluene, which means that we can come to Chemcad and then specify the properties as they are given. We are given the density as 900 and then the viscosity as 0.62 millinewton second per square meter. Okay, and please keep note that we have to check this for Chemcad to use these figures as given here. In the previous section, what we have done is we have played with the pump by changing the outlet pressure and then checking what the pressure here will be. As long as it's very close to 1.1, then we were saying that's okay, and then we have said that the calculated power will be the power required to supply the fluid from the tanker to the floating roof tank. This trial and error was only done just to give you an indication of what exactly we can do, or what Chemcad can do, or just to give you a feel of your way around Chemcad. The better way to do this calculation will be to use the controller here. What we're going to use is we're going to use the controller unit operation. The controller unit operation, you can use it to control a specific, say, variable to be to match given conditions. In our situation, we are going to tell the controller to change the pump output pressure until a condition of stream 3 being the pressure is equals to 1.1 bar. So we are going to control the pressure in the output stream here, stream 2, or the output pressure in the unit operation pump until the pressure of stream 3 is equals to 1.1 bar. Okay, we will just take the controller and then we will connect it into stream 3. We can just reroute stream 3 and then connect. Then we can rearrange and align our flow sheet as we would like it. There you go, neatly aligned. Take a look at the controller dialog box here. You have the controller in the operation mode of the controller. You have the controller off, controller feed forward, and controller feed backward. We are going to be using controller feed backward. In this operation mode, you can see that the controller, you can have adjust this variable, which will be the variable that we will be adjusting until this is equal to this target. So we are going to be, let's just pull this to the side here. We are going to be adjusting the pressure output of the pump until pressure of stream 3 equals to 1 atmosphere, which is 101.325 bar. Okay, we are going to be adjusting unit operation 1 variable output pressure. We will choose the minimum value. Let's take it as 1, which is 1 bar, and let's take it at 1 atmospheric, which is 101.325, and then we can take it as high as 5 bar. That's output pressure. The unit is still that of pressure, and then we are going to adjust this until stream. One of the things that you have to be careful about minimum and maximum value. As Chemcad calculates for the controller is calculating for the output pressure, the minimum value can be used, and if you have specified the minimum value here to be less than the input pressure here, you can end up with the problem or an error in Chemcad, and then this the controller solver not converging. That's why I have chosen to just make it to be the same as the input pressure. So sometimes when you get errors, just be careful that you specify your minimum and your maximum value in the right Our target is to make the pressure of stream 3 to be equals to 1 atmosphere. So stream ID number 3, the variable that we'll be working is pressure, and is equal to this target, which is a constant. We'll be making it 1.01325, which is 1 bar. The units are that of pressure, which is 1 atmosphere. The units are that of pressure, and then we can go okay. In this mode, our simulation should be, our flow sheet should be now simulating in such a way that we have a stream coming in. We are elevating the pressure using a pump, only to overcome the pressure drop due to the friction in the pipeline. I have just realized that I made an error. The stream is coming in at the pressure of 1.05 from the tanker, which is nitrogen blanketed, and then we need to send it through to the tank, storage tank, which has a floating roof, which exerts the pressure of 1.1 bar. So we will need to come and change our targets here in the controller. Our output is supposed to be 1.1 bar, and just for avoid that error, let's just make this one to be 1.05, which is the pressure of the inlet to the pump. Okay, everything seems fine at this point, so then we can assume that our flow sheet is ready to run. Let's start running it 1 unit up at a time. Let's run this unit up. Let's run the next unit up, which is the pipe, and then we can run the controller. Everything's every single unit operation seems to run properly on its individual state. So let's run the entire flow sheet. It seems to converge. Then we can come in here and check the pressure of stream 4, which is 1.1. Then we are happy with that. So you can now find the calculated power required at the pump, which is given in megajoules per hour, to convert it to kilowatts or whichever units that you may be required to present the answer in. You can press F6 and you can see it's now 31.75 kilowatts. Okay, this concludes this part of the exercise. We did not do trial and error. We used the controller to target the pressure that we want the stream 3 or 4 to be at, and then we manipulated the power output or the outlet pressure of the pump to get to only overcome the pressure drop due to friction, and then also elevate the pressure from 1.05 to 1.1 bar.